Joyce.
I think we're tired today, Joyce. Sorry. All right. Doorstop that works one of these days. Number first one. 8. Final answer. 2 minus sine all over 3 plus cosine. Number next one. Of x, by the way. 28.
Yeah, this one I had issues on. I got 1 over. Yeah, I got the same thing.
Remember, the derivative of b to the u is b to the u times ln of b. So we need to offset by 1 over ln of 3.
Yeah, I didn't know how to do that one. So I had to literally go on and your calculator. I didn't know how to integrate that.
Sure, I know, but I just said a derivative rule.
Derivative.
So in the forevers, the derivative of b to the u, a number to a variable expression, is equal to b to the u times ln of b times u. So this is 3 to the x, which came from 3 to the x, but it would have an ln of 3, so I offset by 1 over ln of 3 the exact same way I offset for x to the n when I integrate. I offset by the constant that comes from the derivative, right? A constant comes down, I need to offset by that. I'm doing the exact same thing here. I'm offsetting by the ln of b.
Can I ask a question? Can we make that integral an never? Because that's something that I can't.
I think it is.
What's it forever?
Is it forever?
Mm-hmm.
Okay.
Yeah, b to the u should be in both. So it's 1 over ln of b times b to the u. Yeah. I was just trying to explain, sorry, where it came from. That's why it was confusing. But yeah, it should be in the forevers. It should be under integrals of exponential and logarithmic, maybe?
40.
Number 40.
44.
4.
What? I had 8.
Oh, they did 0 to 2, 0 to negative 2, and then did they ask for total displacement or did they ask for the region?
It was total area.
No.
I thought.
Wait, no, I did that right. What?
Wait.
That's true.
What's 4 minus 8 is negative 4?
Did it just say area between, or did it give you any
I
sort of
was
bounds?
convinced that it said between -2 and 2. Yeah.
It did say that, but I think what they did is they multiplied it by 2.
Oh. Hold on, is there more to it than that?
Wait,
Hold on.
didn't multiply by
Hold on. Is there more to it?
Oh, that might be the first part of it.
There you go.
Oh, it was total area.
Double it.
Yes, I got it right.
And it drops the values.
Yeah, it's an absolute value.
Oh, you did 0?
Sorry.
But remember the symmetry, so with the symmetry, let's see. With the symmetry, you can just double it, right? So once you find 4, just double it to make 8. Or once you find -4, make it positive and then double it. Is that okay?
Yeah.
Number next one.
48.
Oh, this one was.
I don't know how they got the area of the rectangle. Like, I didn't know how to. No, how do you get the height though? They didn't give you a height.
I plugged it into my calculator and I found like where
No.
Found the point.
No, look.
it's just half.
It's sine of x. You just plug in 5 shifts. Just 1/2 times
Because it hits at 5 or 6? Is that where the rectangle is defined to be?
yeah. It's 2 pi over 3 times 1/2. That's the area. And you should integrate from 5 over 6 to 5 over
Do you
6.
have the sine curve? No.
It was just
hump.
It was already a pi. No, only pi.
5 over 6, or well, 0 to pi.
Right?
Yeah, right there.
Except
Sorry,
there's
I
a
was getting there.
Oh,
No, you're good. But that's right.
Yeah.
Although maybe it should be in a little more. And then there was a rectangle hitting here.
Yeah.
Remember, this height is defined by this angle, so if that's pi over 6, and the height is defined by f of x. So that would be f of x equals sine of x. So the height here is sine of pi over 6. So the height is sine of pi over 6, and then from pi over 6 to what was it? 5 pi? Oh yeah, pi over 6. That'd be 4 pi over 6. So this would be 2 pi over 3. And this would be at pi over 6, what's the y value? Plug it in. Does that make sense?
It's funny. I was doing this one,
Uh-huh.
and I almost did the integral from 0 to pi, and subtracted the rectangle and the 2 triangles.
Oh, yeah, no, that
And I realized, wait a minute.
Yeah.
Number 52.
Oh, did you have a question on this one though, Ben? Okay.
Oh, we were allowed to use a calculator?
Mm-hmm.
That
It
is
says
so
use
much.
today.
Oh, yeah.
I literally have find average value and I was like, oh,
You're like,
like this doesn't work.
yeah, you would. You couldn't.
0.994. Wait,
So it's good that you were stuck if it was
wait, 52?
Yeah.
0.914.
It said find an area between the x-axis.
It's like for
Find
an
average
average value.
Really?
Yeah.
So 1 over b minus a, so.
Oh, I looked at the wrong problem then. B minus square root of 8 minus 2 squared.
Oh, yeah. You must have
Oh,
been on,
51.
you were on 51, yeah. Good catch. So if you got on 51, 8.886, that's good. Remember next one.
Really cool.
Why'd you give us 2 free responses?
I know, from a meaty.
Square root cosine x from -1 to 1.
And we did one yesterday together.
I know, see, it was meant to help. All right, how are justifications go?
Can we do it?
They didn't ask for justifications on that.
Yeah, it did.
Which one?
On 58, it said give reasons.
Well, I mean, there's not really much reason you can give to A.
No, besides saying s prime is
Yeah.
equal to f, and then just say f of 5 equals 2, right?
2?
Sometimes you just have to solve and there's no ones that require an explanation, like B.
Yeah. B, you either talk about the slope of f being negative, right? The slope being negative, or the graph decreasing. You couldn't talk about both.
This is the one I had a problem on because it looked like a point of inflection for me.
I got your thumb.
Aww. Fine. What?
I saw B as a point of inflection, so I'm like,
No, they're just asking for negative.
So the slope's a negative of
So
No,
they're
what?
just asking where the second derivative is negative, and the second derivative is the first derivative of f. So given f, you're just looking at the slopes where the slope's negative.
where the slope of f prime is negative?
Well, no, don't you have a graph of f?
Yeah, the,
Yes.
well, they give us the integral of, or something, they give us the integral of 0 to t of f of x dx, and then give us the graph of y equals f of x. 0 to t of f of x dx. And then they give us the graph of,
And that's s, right?
Yeah.
and then they give us the graph of y.
Yeah, so your graph is of f, so then your s prime is equal to, according to fundamental theory of calculus, is just f of t, and then s double prime of t is equal to f prime of t. So this one, s prime or velocity, is the actual graph or the function values, and this one, which is acceleration, is the slopes, are the slopes of the graph or of f of x, because the slopes are the first derivative. So we're just saying when acceleration is negative, the slopes will be negative, and the slopes will only be negative when the graph of f is decreasing or when the slopes of f are pointing down.
Yes.
And that's going to be over an entire interval.
It asked at 5.
Then,
Oh, then you just had to look at 5 and just say, hey, is the slope down or is the slope up?
It looked like a point of inflection to me. It looked like a.
Yeah, but the slope is still not concavity. Slope. So was it going down at 5 or was it going up at 5?
It was going like this.
So
it was a little squiggle, but it wasn't that much of a
It was-
squiggle at 5.
Decreasing.
No matter what, it was still constant, it was still decreasing.
oh, okay. So what they're saying is it didn't flatten.
Oh.
It just was it was a point of inflection, but it still stayed negative the whole time.
So it wasn't an x cubed. It wasn't the horizontal tangent.
Looking at the graph, there wasn't a horizontal tangent. There was a point of inflection. Well, I guess I do like this. There was a point of inflection, but even at the point of inflection, it was a slope down.
Is y equals f of t the same thing as y equals f of x?
You would want to use f of t specifically because f of x was just the notation for the integrand. T is what happens when you take the derivative and it comes in.
Yeah, that's why I was a little confused.
Does that
I
make
think
sense?
they gave us the graph of y of f of x and f of t.
Oh, I see. But we can say that the values, like the notation wouldn't be proper to say that s prime of t is f of x. So I was thinking they take points off to be written that.
Oh,
But we can still refer to the original graph, because if you had f of x being, for instance, like x cubed plus 3, and if f of t was t cubed plus 3, they're going to behave the same way, so we're okay. Does that make sense? you guys have another one? Did C work out okay? So you just had to integrate, and it was just a triangle?
I was really confused and then I realized, yeah, I'm stupid, it's a triangle.
Oh, because you were
I was
thinking, where's my function?
Yeah.
They were trying to trick you.
Actually, one of the smart people.
D.
Oh, E, F, and G.
Why does S have its largest or maximum value at 6?
The biggest area under the curve.
Yeah, base is going to have the biggest displacement.
Yeah.
You could say the positive displacement is bigger than the negative displacement after.
I was gonna say that, I only said it because that's when the acceleration was highest and it's been increasing up to that point, and after that it just goes down. So I'd say that it would.
We can't say that acceleration is highest there has anything to do though with S being highest.
No velocity.
Oh, you meant velocity.
Mhm.
Velocity is highest there?
And it's been increasing that whole way. So if it's just getting farther and farther and farther faster.
You could probably describe that in a paragraph. It'd be more precise to talk about the actual area being the positive change is largest at that point. And to call it a critical number, you know that that's the changing, because it doesn't go negative after that.
Yeah.
You could say the integral from 0 to 6 is greater than the integral from 6 to whatever. Or you could say the graph is strictly increasing and then it's decreasing. Is that what's going on?
The graph is positive until 6 and then it's negative, so S is gonna be.
So you could say position is
Yeah.
strictly increasing to 6 and then decreasing after, so that has to be the absolute max.
Well, we talked about F and G because I was.
Yeah. Is E okay? 4 and 7?
Yeah.
We also check out 49.
Oh, I thought it was like 3 lines on 42.
59 for the answer?
Yeah, let me see. 'Cause- No, like the number 59.
Oh, it was like that. The one we did in class. Got it.
Can you scroll down one more?
Oh, you want to look at?
Yeah, I'll follow it.
Miss D.
I thought we were going to look at F and G.
Oh, did we not yet? My bad.
No, you're good. You're good. Amanda, that was your question, right?
Yeah.
Okay, so try to hold on. So for F, we're talking about the
Particle moving towards and away from the origin. I don't know how you know where the origin is or what that means.
I know.
Isn't it 0, 0?
No.
origin. You can't think about on the graph before you, because the graph before you is just showing changes in position, values of velocity, and signs of acceleration.
Right.
Indicative of. But depending on the situation, almost always when they have a particle moving away from the origin, if he's moving away from the origin, where's your initial position?
Origin.
Why?
0, 0.
Right.
So 0, 0 was the initial position. So they're just saying from the initial position, does he end up, where is he positive to the right, having positive displacement, and where is he having negative displacement?
So
Wouldn't
Wait,
it be y values?
what is the actual question? Sorry.
it says when is the particle moving towards and away from the origin?
Oh, towards and away. Okay, so towards the origin and away from the origin. Towards the origin would be what kind of velocity?
Positive.
Positive. So it's
Because moving to the right, and then
So slopes are positive versus slopes.
towards the origin would be
Negative.
negative coming back.
okay.
Um,
So when the slopes are positive, then it would be going away from the origin.
You'd be going
right,
towards-
unless it,
No.
well, okay, looking at your picture, it starts with a positive displacement, right? So we know it's moving right, and we know it starts moving left. And it doesn't ever come back to the origin, because the positive change is greater than the negative change. The reason I'm saying that is if it was moving this direction, away would be negative and towards would be positive. So in reference to our situation, where is the velocity positive, where is the velocity negative? Does that make sense?
Oh, so just when it's positive, so it's.
So you can think, yeah, positive displacement moving away from the origin, negative displacement coming back towards. Gerardo?
On a graph, it would only be going positive to the right. It would only be going this way, right? But in reality, it's describing like this, because like the y values are
Well, on the graph of velocity,
No,
time
not
is just
position.
going.
position.
Well, position, since you have positive area and negative area, then it's going to the right and then to the left. Positive displacement means you're moving to the right of the particle, if it's just linear, and negative displacement means you're coming closer, so you're going the other direction.
But on a graph, would it look up and then down?
No, this particle is just moving in the positive direction, I think it's just linear, and we're assuming it's right-left, so from the origin it's just going like this.
No, but wouldn't the y values describe?
There aren't parametric equations for this one, so there is no y value being described. It's either straight up, down, or right, left. If we had an x and a y, then we could be describing it two-dimensionally. Does that make sense?
Yes and no.
Okay. Keep pondering that one. 59. George, do you have a question on the bed?
I just want the picture.
Oh. Hold on, let me see if I can get him. There you go. I got him. Do we have any other evens, guys?
No.
We're good? Okay. Were there any other huge odds that we had questions on?
Wait,
67 was weird.
I got that one.
Oh, hey, he's D. Go team. Okay. He was the multiple choicey one, right?
Oh, this is the one I was talking about. The Slater dude was weird.
Slater. What are we gonna do with that? Collection of tons of people. Can't really call him a guy, huh?
Misty, on number 59,
Uh-huh.
it says that it passes through the origin at 6, but the graph is positive from 3 to 9. So I don't know how.
The particle passes through the origin at t equals 6.
What?
Wait, somehow it. Oh, but remember, at 3, time has already moved. It's already moved away from the origin, and specifically, if you look between 0 and 3, it's moved left of the origin because the area is negative. So it moved left of the origin, and now it's moving right.
Oh, because it's 3 to the left and 3 back to the right. Got it.
Does that make sense?
Yeah.
Miss D,
Yeah.
on 58, if the x's were time and the y's was displacement from the origin, like left, right, up, like positive y's are to the right and negative y's are to the right.
Hold on. Why are we going x's and y's? Can we do t's or time?
Yeah. So t and y. So t goes up and y tells you.
Wait, is y s? Because they gave us s, right? So is y s or is y a random other new
Y is
variable?
s.
Okay. So we have s and we have t. Okay.
And then so then y's, if it's a positive y, it means it's going to the right. Right? And if it's a negative y, it means it's going to the left. It has left negative displacement. Not up, down, left. Just left, right. Right?
If there's only one equation describing distance, then it's talking specifically about one direction.
Right.
Positive and negative.
So if you have velocity and you realize that the area is the negative area is greater than the positive area, then you have to realize that it went out to a positive displacement, positive y's, and then it went a further negative y's, negative displacement, so it's going to be on the left of the origin, even though the position graph is going to be still to the right.
At a point, if it ends up left of the origin on the position graph, it's going to end up left of the origin as well. Unless the position graph is a graph of how far it is from the origin,
Yeah. That's what it is.
and it's not showing the actual movement itself.
Yeah, that's what it is.
Okay, yeah, I'm tracking.
So it would be you'd have to realize that it's still going to be in the right origin, but the particle itself in reality.
Well, you have to realize the graph you're looking at is not the actual path of the object. It is just showing a change in or a displacement over a period of time. So it's not like an actual animation of where the little thingy is at each and every time. Okay, so Amanda, you said number 59?
Oh, no. 67.
67.
If it shows that it's mostly a negative displacement, does that mean that the particle is to the left of the origin?
Mostly negative. I'm not sure what that means.
The display, like the S is like goes positive, and then but it goes way more negative. Does that mean that the
Well, it starts off, if it starts positive, then it starts off to the right of the origin, but then it's going to go to the left of the origin, and then if it keeps on having more and greater negative displacements, then it's going to not come back to the origin.
it's gonna pass it, right?
Oh, I just said it moved to the right, and then it passes the origin, and then it won't come back. Struggle. All right, last one. Composition books are close, and here we go. multiple choice gives us the following equation of f of x equals a to x of ln of 2 plus sine of t dt. Oh, this marker's killing me. It sticks out. All right. Why is this one weird? How's the antiderivative? You guys have fun?
Yeah, calculator helped me a lot.
So one more time. How is the antiderivative? You guys have fun?
I need to worry about it, do you?
Nope.
I was so
The antiderivative would have been brutal. Actually, it would have been near impossible. So, were you supposed to find the antiderivative? No.
No!
You were supposed to use our clue from yesterday. How, if you have an initial condition, you can go ahead and talk about f of x by, you can talk about f of x.
3 to x,
3 to x.
and then equals.
For instance, if you know f of 3, you could say, hey, let's start at 3, and then x is 3, because we can make a whatever we want him to be. Then we can do ln of 2 plus sine of t dt, but that's going to be 0, and I need it to be instead 4. Then I can say, hey, I can generalize this for any x, not just 3, now that I've set it up. And why is that cool? I don't need to be able to antiderive to find another clue, which is pretty spiffy.
Question. How does our calculator antiderive that, but we can't?
They use,
Does it really?
I don't know exactly what the program is built upon. My guess would be that it's built upon much better approximation methods than our leading sums thus far.
Because, like, you can't antiderive that. You can't even use it.
No, but you can find it approximately using approximation methods to as many decimal places as can fit on your screen.
Is that how they
So
do?
you're saying the calculator has the exact value? Probably not. It probably has an approximation, but a very, very good one that matches the exact answer up to that value. And if you